43, point W is located at 2, 3 on a coordinate plane. All right, so if we create a coordinate plane, and it's mentioning 2, 3, and I don't see any other numbers there, so what I might do is bring it up to 5 and try to split things into 5 parts. 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5. Try to do that everywhere. So 4, 3, 2, 1. This is -1, -2, -3, -4, -5. I'm trying to do this freehand, so that's symmetrical at least. 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. And this is going to be -1, -2, -3, -4, and -5. And let me change the color of the ink so that what I'm going to draw is not necessarily interacting with the blueness of the numbers. Let me make it red because that's defiant. Yeah. Okay. So let's try this. Point W is located on -2, 3. So this is x comma y. Remember, we want to move the ladder back and forth horizontally first, and then go up and down to find the book that we're looking for. So we're going to go to -2, 3, which is right there. Okay. Okay, so point W is located there. It's reflected over the x-axis. So this is x, and this is y. Okay, to create point W prime, that's called. See that little tick mark on your keyboards? That's a shift. It's actually below the double quote. So you would shift double quote. It's without shifting. Okay. So it's reflected over the x-axis. Okay, so just to be clear, if I have a mirror that I put down, this is the mirror here. If there was a dot here, that dot's going to appear there. If there was an X here, it's going to appear here. The X is not going to appear right there. If I put a Y over here, it's going to be over here backwards. So that's going to be what? It's going to look like, no, I didn't do it backwards correctly. It's going to look like that, right? And if I put another dot here, it's going to be over here. So that's reflecting it over the y-axis. So if I had something like this, and if I put the letter U here, if I reflected it over the y-axis as if it was a mirror, it's going to look upside down like that. Okay? All right? So that's the two things they're talking about. This one was reflected over the y-axis. This is reflected over the x-axis. Okay? So it says W is reflected over the x-axis to create the point W prime. And then it does it again, they said. So let's stop here and figure out what this sentence number 2 is all about. So if we reflect it over the x-axis, it's going to be the same -2, but it's going to go down 3, right? If there was a mirror along the x-axis, it's going to reflect straight down. So this point, the original point was -2, 3. This is the W prime is going to be -2, -3. Okay? Right? Does that make sense? It's going to reflect the same, this distance here is going to be the same distance right there. Okay? Then the next part, and this is somewhat unfair because if you got this wrong, you can't get the next part right, is reflected over the y-axis to create y double prime, right? They're using y prime prime, okay? So we're going to do the same thing. This time we're going to reflect it over the y. That means this point is going to be over here. So W double prime is going to be 2, -3. If you notice, we went from -2, 3 to -2, -3 to +2, -3. Okay? And again, in this case, we would have put the mirror along the y-axis. and it has to reflect out. So again, this dot here looks a little further than here because of my drawing, because I kind of drew this sloppy. Actually, no, you know what? I did put it in the wrong place. Let me correct that. I put it at 3. It should be right there. So it's over 2, up and down, so it's down -3. Okay? So excuse me, please. All right, so that means this distance here is the same as this distance right there. All right? Okay, there's a second way. So we're up to here at this point. So what ordered pair describes the location of W double prime? It'll be 2, -3. Okay? Explain how you determine that. You could say if there was a mirror along X, the X position doesn't change because you're reflecting it over. That's what it's flipping over, if you will, to come down to here. Okay? To get W prime. And W prime to become W double prime is the same thing. If I put the mirror along Y and I flipped it, it's going to be equidistant, but at -3. All right? So there's other rules that we can figure this out with, which partially involves memorization. So if I have point X, Y, and I flip, or let's use the correct word, reflect, over the X-axis, that's going to yield, we leave the X alone, and we negatize the Y. So if we use the example they started out with, -2, 3, okay, that's going to mean I'm going to make it the X comma minus Y. So I'm going to get -2 because the X stays the same, and 3 was started out as the Y, so I'm going to -3 it. Okay, that turns out to be the point that we got right there. Okay, and if I take a point X comma Y and reflect it over the Y-axis, I'm going to leave Y alone and change the X. So this becomes -X comma Y. So if I had -2, -3 here, I'm going to basically get a -2, and I'm going to leave the Y alone. So that's the same as a minus is a +2, comma, -3. Okay, and that's our second reflection, which turns out to be this, 2, comma, -3. So that's what's going on there. Again, I'm glad they included this kind of thing too. This normally occurs in later years and later tests, but that's cool. That's awesome. Reflection, these are in the category of thing called transformations. We can move things, we can dilate them, which means making them bigger or smaller. We can reflect things, right? And there's a fourth category that surpasses my brain capacity at this very second. I don't remember. In any event, look up transformations and you'll see other categories with that. So that's 43. So this involved coordinate geometry. It involved geometry then. It involved point manipulation, if you will, and particularly reflection. And check out GregsTutoringNYC at gmail.com/hottest-math. You can email me at the bottom, GregsTutoringNYC at gmail.com. And I'm going to give you guys double piece again. Where's the camera? Right there. Yeah. All right, guys, take it easy.